Hello, and today we're going to talk about what momentum is. Momentum is a way of thinking about a traveling object in which we link together both the mass and the velocity of the traveling object. And there are a lot of questions and topics within this area. For example, the difference between elastic and inelastic collisions, relative velocity or speed, as well as what the principle of conservation of momentum might tell us. Let's first of all talk about what momentum is. And as I said before, it's a way of linking the mass as well as the velocity together. Let's say a truck which has higher mass is traveling at 75 kilometers per hour, and a car is also traveling at the same speed, but it's much lighter. Let's say if it collides with another car going backwards, the car would stand not a chance against the truck, which will probably keep moving, but it may also stop the other car from stopping altogether. And this is what momentum is. It's how much of a force it has to keep going. It's the product of mass times velocity, rho equals mv. The unit is kg meters per second, and it's a vector quantity. And that's obviously because the velocity is also a vector quantity. So we have a principle of conservation of momentum, which is very important in this topic. And the principle of conservation of momentum tells us that within a closed system, the total momentum is always conserved, and in any direction as well, because it is a vector quantity. And so the closed system means that there is no external force, which means that within this certain interaction, only assuming that there's no other debris carrying some momentum away, the total momentum is always conserved. They equal each other out, which means that the total momentum of all the different objects that were in the collision after the collision is equal to the sum of the momentums of the various objects before the collision. Let's look at a few metal balls, for example. Let's say there's a 2 kg metal ball and a 1 kg metal ball. They have a combined momentum, which is in the brackets, of 0 kg meters per second. After the collision, let's say this other ball has a 1 meter per second velocity. Well, we can deduce what the other ball would have. It would be 2 meters per second, because then is the only way that the total momentum becomes 0. And we know that the momentum before the collision was also 0. And that's how we use the principle of conservation of momentum to solve equations. Then we also need to look at inelastic and elastic collisions. So if you've ever been in a car crash before, or if you just watch the news, you might see that cars actually do get crumpled and deformed after a car crash. Their shape changes. It makes a horrible sound, sometimes even fire. And this means that energy is used. For example, sound energy or heat energy or potential energy. And that all comes from the kinetic energy, which has been transformed into other energies. That is inelastic collision. Then what is elastic collision, you may ask? Well, let's picture two metal balls that collide together and then separate. They rebound and they don't get deformed, they don't crush, they don't make a sound, and they don't make any heat. There's no energy transition at all. All of the kinetic energy is conserved. So basically, the difference between elastic and inelastic collision is that elastic collision and inelastic collisions both have their momentum conserved. But in an elastic collision, the kinetic energy is conserved. In an inelastic collision, sometimes it's changed to different forms of energy like sound and heat. As well as in an elastic collision, the relative velocity will remain the same, while the inelastic collisions won't have it the same. For example, these two balls have a relative velocity or speed of 5 meters per second, and so after the collision, it should also have the exact same relative speed, although it might have a different distribution of it. Now we can link that Newton's 3 laws of motion and momentum together. So you might have learned earlier that the Newton's second law of motion tells us that F equals ma, and it's the whole thing with the proportionality to acceleration with force and mass. Well, we can alter that equation a bit, and we can link it together with momentum, and what it tells us is that the resultant force that is acting on an object is directly proportional to the rate of change of the linear momentum of that object, and also that the resultant force and the change in momentum are in the exact same direction. What that means is that when a resultant force acts on an object, the rate of change of momentum that the object will get because of it is literally equal to the resultant force, and it's also in the same direction. We can also represent this by showing that F equals delta rho divided by delta t, which is the rate of change of momentum. Remember that it is divided by delta t. We can also talk about it in the third law, and that tells us that when two bodies interact, the forces that they exert on each other are equal and opposite to each other. And how we can relate that to momentum is basically we can just say that the rate of change of momentum that they exert on each other because of the forces are also going to be equal and opposite to each other. So these are the two different ways that we can relate the second and the third law of motion to suit that of what we've learned about momentum. And so that is all for this short video on what momentum really is on the later years of high school level, and I hope it was helpful in any way. And you could also check out my other videos about other physics videos on this topic and this level, and it would help me a lot if you subscribed a lot. So yeah, thank you for watching.